So we're going to spend some time here this morning calculating the length of the Arch of St. Louis. If you're not familiar with it, let's take kind of a quick look at it. That would be this one right here. It has a very specific shape that has a lot of neat history to it. It's called an inverted catenary. Now, the shape is actually derived from a function called a hyperbolic cosine. It's probably not something that you've encountered so far in your mathematics career. It is actually a function that you can find on your graphing calculator. Now, a couple quick things about the hyperbolic cosine. Let's see. I believe that cosh of x is defined in terms of some exponential functions. Going to be e to the negative x plus e to the x over 2. I believe that's your hyperbolic cosine. And you can use that to show kind of fun things like the derivative d by dx of the hyperbolic cosine, cosh, is the hyperbolic sine. Now, I'm not going to hold you responsible for hyperbolic sine and hyperbolic cosine. There is one nice thing that is true about these things that I kind of like. The derivative of the hyperbolic sine is just a hyperbolic cosine. What's different about these two than our, trigonometric analogs?
There's no negative.
Yeah, there's no negative, which is kind of nice. Now, like I said, I'm not really going to hold you responsible for too much about these things. My goal here is to help you calculate the length of this arch using numerical integration. Now, one quick thing about this. This is called cosh, and even though there's no c in there, a lot of times people call that sinh. So, okay, great, nice. Let's see about calculating the length of the Arch of St. Louis. So the first thing I want to do is I want to put in the function for that for the Arch of St. Louis, and you can Google it. I've kind of rounded out a couple digits here, but here's our function. There are more digits of accuracy available if you wanted to Google those, but I didn't want you to spend forever typing in this function or our limits of integration, so they're a little bit rounded. So the first thing I'm going to do is I'm going to type in the function. Well, let's see. So that function is going to be 693.86 minus 68.77 times hyperbolic cosine. Now, in case you forget, I've got a little thing here for us on our sheet as to how to get to the hyperbolic cosine. There's actually a couple ways you can do this, but if you hit the second key and then the 0, that takes you to the catalog. And then you can eventually scroll down. If you kind of jump to the letter C, then you can scroll down to find your hyperbolic cosine. You'll find it down there, cosh. It might actually be easier to jump to the letter D and scroll up. Right now, I have us jumping to the letter C and then scrolling down. Certainly you don't want to scroll down from the very top. So second, 0. Instead of jumping to the letter C, I think I'm going to jump to the letter D. So I'm just going to hit the matrix key and then scroll up until I find cosh. There you go. Make sure you don't get the inverse of that. Select cosh. And then, let's see, we want 0.01003x. And then an x, parenthesis. And I'm kind of worried that there's this other little x up here. I don't know where that little x is. If you want to get to the end of your line, if you can hit the second key, then the right arrow that'll take to the end of the line. Yeah, it looks like there's an extra something up here. Let me get rid of that. There we go. Now let's think about the formula we're going to need to integrate. In general, when you're trying to find the arc length, it looks like this. Your arc length is going to be integral from a to b of the square root of 1 plus dy by dx squared dx. So that's essentially what we want to put in for our integrand. It becomes a little bit of a pain. What I'm going to do is let our calculator do some of this work for us. So for instance, instead of me finding the derivative of this thing explicitly and putting it in here, I'm just going to let my calculator do it. How am I going to do that? Well, just like you have numerical integration, you have numerical differentiation. I'm going to put that as my second function in here. The second function is going to be the derivative of the first function. So that's our little trick here. Let's see if we can't do that. Go back to our equation editor. Let me clear this up so you can kind of see the keystrokes that I make. So I want the derivative here. You're going to find the derivative the same place that you find the integral. So instead of math 9, it's going to be math 8. This is derivative with respect to what? Well, with respect to x. A derivative of what? Now you've got two choices here. You can type in this equation again. You can type in 693.86 yada yada yada, or we can be a little more clever about it. For my money, we've already typed this in once, right? Why type it in again? The workaround that typing it around again is to go to the vars key, and then you see y vars, so go to the right. The first one there is function, and it says, well, what function do you want there? Well, the function that I want there is what was in y1. So we'll press enter, go over to the right one more, and put in x here. So now you're taking the derivative of y1, and we got everything set. Let me do one other thing here. Let's go up here and to the right, put your cursor on the equals sign and press enter. And you're toggling this off. So if you were to graph this, you're only going to see the graph of y1. You're not going to see the graph of y2. So we can take a look at this if you'd like. As far as our window is concerned, let's set up our window from negative 292.2, or excuse me, negative 299.2. And it's going to be symmetric, so up to 299.2. As far as how many tick marks or where you see your tick marks, we probably don't want to leave this as 2 because that would give us close to 300 tick marks across the bottom of our screen. That'd be kind of a lot. So I'm just going to make this something like 50. You could do 100 if you want. Now, as far as the y graph is concerned, the y coordinates, you might be looking at this going, yeah, I have no idea what these are going to be. And that's fine. If you set up the x values, your calculator can figure out what the y values are. So hit zoom and then 0, and you should get a nicely fit arch into your calculator. You guys able to get that? You guys with me on this one? Brain? Hannah? Okay. Let's find the length of this arch. So to find the length of that arch, really what I want to do is I want to calculate this limit, or I want to calculate this integral. I need to put in the limits. In fact, I got to match exactly what I have here. So let's do that. To do that, we're going to go back to our home screen. So you can hit the clear button, get back to your home screen. Math 9. Somehow I think that's the only thing you guys have memorized. Like, it's been your go-to for over a semester now. So negative 299.2 up to 299.2. And now I need that square root term, so it's going to be square root of 1 plus. Now I really don't want to have to type in the derivative here and then square it. But I don't have to, because I've already got the derivative. Where is the derivative for us for this problem? It's in y2. So let's go find y2, and then we'll hit the square button. So vars, then y vars, enter, and now the number 2. And then you can hit the square key after that. So now you're squaring that. Last but not least, remind your calculator that we're integrating with respect to x, and you should get something around 1466 maybe? No, 1478. How many people got 1478? All right, well done, well done. Now there's other ways you could do that, but I think this is probably the most efficient way that I could think of, and I'm happy that you've picked that up. Any questions or comments on that one? Yes?
Could you show me how you got the y2 again?
Sure. So just so you know, when I'm doing these types of problems, you kind of see the keystrokes here at the bottom. But since you didn't quite catch that, let me go back and show that one to you. So you go to the vars key, and then you go one to the right, press enter, and then you select whichever function you want. In our case, we wanted y2 because that's where the second derivative was, or the first derivative was.
Okay, thank you.
All right, you're welcome. Anything else? All right.